whatever we do. Jioni safu no la with whatever we do. Hale yide munyu skula, nyepamne ne kudlukula. Nyepangi ragala gena, nyepamne ne kudlukula. Ibuloke nongoto ni beti sola. Ibuloke dato ni betoto.
Bigi Congo.
Lamin.
Na?
Lamin te jibe norin te nya Lamin.
Kabana wulo kono.
Wulo kono nyinta mo Lamin.
Pabilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyola.
Ngoto le Fabrama.
Namu jumala kan kuma diten.
Fabrama.
Jumala mu.
Ndele bare muso.
Nunda mana. Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani bana na mundu wa kontan.
Ngoto minaka ngala min de fom filitala. Lamin jibe nori nya.
Lamin ila siran sama ne benki. Yala so tol sayni no ko mo lokko momo.
Ngoto.
Nam.
Iterinte yalo ne Lamin hakilo diata bake karamungoto. Anu sainteng ministry ko di ngole si suko na amanke ko do holiday
si bitun
bagona de
ala ni ko kede namo balo
ala ni na ko na karta bulo be damen ala ni je
ngodo
nam
ngoto mon kontan feren
jamani mu ne keda
ifika Lamin ki wulo ko no nyintay mon ko do fete malo Lamin nyanta sila la be la moy kala karango
jamani karamol be soron ne ko fasi ka wulo ko no ko
karambo wol ma soron ni ko karambo wol soron da amanke ko holiday lem ngodo dindi wo nyanta sila la ala karango la moy yamen kaben fue man kontaan anda mande
alla nyin kombo courant alla kombo len do la jankara mol soron do kamen courant ma ra do la kombo e ko ndol fanena kara mol soron je kara mol soron Lamin ada lo nyino la amanta ra fena sokon ala mu nekela
Lamin ite foyde malon ko lesinol be ke kar radio to
nga fine
e ko nyani mo Lamin
nga fine
ya mu na fonye
bi kabin mina kan tambita nteri maning Fatu tambite la sukol ala dinngol bebe siri be la moyka
faru dan so am fanan kamira jele ni subala la ngaje dinngol be jet talanta nen kili waro e be serin jelet
sa Lamin farante ku kili wo ke no la ba Lamin bita ka wulo ko no nyinta mo Lamin
amandara fennela
ite dine ko ni man si yakaru lesino la moy radio to e balon na
mu ne ka ke afonde ma nyaara ni alon
telentel jikot
afonde ma mu de be ke
ite balon tel be jikritel ni man karambe ku kele yaaje nata karana mbasa malaya ay tarije
par ñarande kombo courant ho findira kombo ide nara yede ni sonka bay ko Lamin manya tala wulo ko adu karam wolbe so da fa ñembe
ko to wole nati bawo ngal le Lamin kuntal kombo courant o ka fa me kombo courant asototal wala kinay ko e sisu kono bari ni ko e sisu kono be karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto la bungo bar radio be bulan koto batiri sanga ay si ay alamo
sa do kala nyaadi
ko ta o bulaji
ado kala nyaadi
kamun ke nyaadi
radio abe wala moy la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karande
ile subjector baby jele baby jele
wala nanga chocho moy fa dan so wolya ngombe tambi kana ngadi ni wolje be ikadum bungo de ko kada maro
ma asototal de
Lamin mala be karawala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko di ko nde ko folle sinila mba ndele sinilo ne ba
mba say mba foke en koto wole fango yen wulindi yalo famo keta bat yu fanam bulata kol ko me yen nati jambi Lamin nyanta karana ntel be jiko be nyineka ya bulay kara wulo kana ta kilar ya bambalo yo be bulaje koto dindi ngoy si ayala le sino la moy radio
wala ka munda kara mo man soro Lamin nyanta kara si so na
radio sila le ayala le sino
dal ko malon
kilar ya
be ngala ko momo sa mi do ni ko no kera
mengi bruzo
ndelo ko do la da barro sa no radio ba no bari woro radio ni abe jele ba do ngamra do man dembe buljan dala nyara nyar woro ko fendi mo la Lamin tayra barro sa
bara te ku folo ajibe nori nya labi tamete ku
teku
bari ko do famo ke
imagine nani nyambol sizol le keje kisigi man sizol no le kabun ka nyoma bari nyambu kilo ni manya na kafindi ni nambe ko so laga
ngale limbeta de be nyambo do dilanna
nyara ni ko rim fennat nyara nata
bari famo ke da
ngata bungono tammi bungono nyara ngando ko fele ko ke baru nganda ni pelo la ndija
iyo awa
la bungono bismillah bisu diara
pendulala yefu ngotanka sina dolutanka koro korota korota
viewers and listeners. Welcome to the continuation of the topic on mixed operations on fractions. The last time we met, I did give you some try questions, which I want us to try together and then see if the solutions we have will be the same as the ones that we're going to solve together. Now, the first try question, we are asked to simplify a 2 over 3. That is a 2 over 3 divided by a 6 over an 8 minus a 2 over a 5, 1 over a 4. This is the question that we are given. So we are asked to simplify this. If you take a look at the question given, you will realize that we've got 3 different operations. What are these operations? You have a division sign, and you have a minus sign, and then you have a multiplication sign. In short, the question is on mixed operations. And how are we to solve questions on mixed operations? We need to remind ourselves of what we've discussed in our last lesson, and that is the board mass. What does this exactly mean? That is, the B here represents the bracket. And if you looked at the operation given, there is no bracket among the operations that are given. The O here represents an off. And if you equally take a look at it, there isn't also an off given. The D here represents a division. And among the operations given, we've got a division sign. What is dividing what here? And that is to say, the 2 over 3 should be divided by a 6 over an 8. Put that in a bracket to simply mean that you're coming to start with this operation. Then minus a 2 over 5 times a 1 over 4. Dividing a 6 over 8, meaning this division sign should change to a multiplication sign. And then the number immediately after that be inversed. And that is, the 6 over 8 becomes an 8 over 6. Then you also maintain the bracket. Then minus a 2 over 5 times a 1 over 4. Then what are we to do here? We have to look among our numbers in the fractions which could divide each other. Now, we all know that the 2 here is a numerator, and then the 6 is a denominator. So in short, what is common to both? Meaning a 2 is common. Meaning the number of 2's in itself is 1, and the number of 2's in 6 is 3 times. So what we're going to have in the bracket as our new fraction will be a 1 times 8, which is our numerator 8, divided by a 3 times 3, which is going to give us a 9. So the division of the two numbers, that is 2 over 3 divided by a 6 over 8, will leave us with an 8 over 9. This 8 over 9 has to subtract a 2 over 5, and then the result be multiplied by a half, by a quarter. Now, if you looked at these new operations in the question given, you will agree with me that we've got 2 operations. One a minus sign, and then the other a multiplication sign. Still, the operations are mixed. So again, we need to reflect back on the board mass. We've realized that there is no B, which is a bracket. There is no of, which is the O there. There is no D, which is the division. But there is an M, which is multiplication. So we've got a minus and a multiplication sign. Of course, in the board maths, the multiplication comes before the what? The minus sign. So what we equally have to do here is to also multiply, take on the multiplication. Now, in the equation, in the operation, we have an 8 over a 9 minus. Is there any number that could take on each other? The 5 is a denominator, and we have a 2 and a 1 as our numerators. 5 can't divide any one of those two. More so 2. But the 2 can take on the 4, meaning the number of 2's in itself is 1, and the number of 2's in 4 is also twice. So what we'll also have in the bracket, that is in the multiplication of a 2 over 5 times a 1 over 4, will leave us with a 1 over a 10. How do we arrive at that? A 1 times 1, that is the numerators, will give us 1, which will serve as the numerator. And a 5 times 2, that is the multiplication of the denominators, will give us a 10. Now, what do we have as our new what? Operation, or as our new question? We'll have an 8 over 9 minus 1 over 10. Both are fractions. And if you looked at the two fractions, the denominators are not equal. One of the denominators in the first bracket is a 9. And then the denominators in the second fraction is a 10. What are we to do? What we'll do here is to make sure that the denominators of the two fractions are equal. How can we make them equal? That is, we must come up with equivalent fractions of each of the fractions that are given. That is, equivalent fractions of the two fractions that are given in the question. And how do we go about doing that? That is to say, we'll have an 8 here, which has to be multiplied by 10, because that is the denominator of the second fraction, all over the 9, that should also be multiplied by 10. Now, if you've done that to the first fraction, a similar thing should also be done to the second fraction, which is 1 over 10. With 1 over 10, the denominator of the first fraction, which in this case is a 9, has to multiply the 1, and then also go on to multiply the denominator 10. Now let's see what equivalent fractions we're going to have. And 8 times 10 is 80. That is our numerator. Then go on to multiply the denominator, 9 times 10, which is a 90. Now, an 80 over 90, when simplified, will be the same as an 8 over 9. So 8 over 9 and the 80 over 90 are equivalent fractions. Then a minus. Let's see what the product of the second fraction is also going to give us. A 1 times 9 is a 9. And a 10 times 9 is also a 90. A 9 over 90, when it is also simplified, will also lead us to 1 over a 10. So what we did was, we've come up with the equivalent fractions of the newly formed fractions that we have. And again, went on to have what? A common denominator. Like if you looked at the previous fractions that we have, that is 8 over 9 and a minus 1 over 10, the denominators were not equal. But if you looked at the second fractions that we've just created, the denominators are equal. And what does this remind us of? That when the fractions of a common, when you have fractions with the same denominators, what we need to do is, if we are adding or subtracting, and in this case we are subtracting, we take the difference. That is 80 has to minus the 9. The numerators have to take on each other, and then a common denominator be taken. That is 80 minus 9, which are the numerators, which will leave us with a 71, all over a common denominator 90. Now let's take a close look at this. 71 over 90 is a fraction. But can this be simplified? Is there any number that could divide the 71 and the 90 without leaving any remainder? The answer is no. There is no such number. Now, can the 94, if you look at the denominator 90, it is more than the numerator, meaning our result could either be in this form or in decimal fractions. Now, let's take a look at the second sample, the second try question. In the second try question, we are also given a 3 over 4 minus. Then inside the bracket, we have a 3 over 4 and a plus 1 over a 2. Then of 4, which is outside the bracket. This was the question that we are given. How are we going to also simplify this? Now, what we need to do here is to first and foremost change all the mixed numbers to improper fractions, if there is any. And in the question given, there is a mixed number. What is the mixed number? It is 3 over 4. This 3 over 4 has to be changed to an improper fraction. Remember in our last lesson what I did, or what we've done together, that to change a mixed number to an improper fraction, the denominator of the fraction has to multiply the whole number, and in this case the denominator is 4 and the whole number is a 3. So a 4 will multiply a 3. The 3, that is the whole number here. 4 times 3 is a 12. Then the 3 that is in the numerator, that serves as a numerator, should be added to the 12. Meaning what we'll have here is a 15. Meaning 4 times 3 plus a 3 is 15. The result there should be divided by the denominator 4. Then minus the value in the bracket, which is 3 over 4 plus then of 4. Is this the answer to the solution? Nothing is done yet. What we did was it's only the transformation of the mixed number to an improper fraction. Now, what is it that we're going to do here? Let's check on to see the number of operations that we have. First, we have a minus sign, and we also have a plus sign that has been enclosed with a bracket, the addition of two numbers that have been enclosed by a bracket, and then an off. Because it is mixed, the rule is we remind ourselves of the board mass. Meaning, if you are given a question in this form, what is in the bracket has to be solved for first. And in this case, do we have a bracket? Yes, there is. And what is in the bracket? That is a 3 over 4 plus a 1 over 2. So that should be solved for first, because there is a bracket. How are we going to do it? Again, we could have a 15 over 4 minus the 3, because they are adding, should be multiplied by 2, and the 4 we multiply by 2. Why? Because we're taking the denominator of the fraction or the second fraction in the bracket to multiply both the numerator and the denominator. Then plus a 1 over a 2. In this case, this 1 over 2, the same treatment given to the fraction 3 over 4 should be given to it. A similar treatment. I beg your pardon. Multiply the denominator of the first fraction, which is 4, with the 1, and then also go on to multiply it with a 2, with a 4. The 2 here with a 4. And then of 4 to complete the question given in the operation. Now, what are we going to have as our new equations? We will have a 15 over 4 minus the product of a 3 times 2 as our numerator, which is 6, and then the product of 4 and 2, which is going to give us an 8. Put that in a bracket. Then plus, which is a 4, and then a 2 times 4, which is also an 8. And then complete the question, that is of 4. Now, inside the bracket, of course, if you looked at what we had initially, the denominators weren't common. That is the 3 over 4 plus 1 over 2. You will realize that the denominators were 4 and the 2. They weren't equal. But what we have in our newly created bracket, you will observe that the denominators are the same. What are we to do here? To apply the technique. And the technique is, we will sum up the numerators, that is 6 plus 4, which is a 10. And then we take a common denominator, which is an 8. Then of a 4. Now, initially we had more than two operations. But now we've got 2 operations. That is a minus sign and an off. In the rule of board maths, which one comes first? The off should be solved before the what? The subtraction. So since there is an off here, that is 10 over 8 of 4, meaning that is what we should solve for first. And in this case, we'll have a 15 over a 4 minus, inside the bracket, we'll have a 10 over an 8. The off here has to be changed to a multiplication. But that does not affect the number immediately after it, meaning it should not be inverse, but should remain the same way. Of course, you will have a 4 over what? 1. 4 over 1 simply means a 4. What I wanted is uniformity, so that I will have fractions in both. Now, what number can cancel out here? That is 4 could reduce the 8 twice, meaning when 4 divides itself, it is 1, and the number of 4s in 8 is 2. Is there another number that could also what? Reduce, or are there any numbers that could reduce each other? Of course, the 2. The number of 2s in itself is 1, and the number of 2s in 10 is 5. Are there any other? No. What is it that we're going to have as our new question? We'll have a 15 over a 4 minus a 5 times 1, which is a 5, all over a 1 times 1, which is a 1. What is it that we're going to have here? Again, the denominators are different. And since the denominators are different, we need to we're going to have here is a 15 over 4. Of course, the denominator of the second fraction, which is 1, has to multiply the 15 and then also go on to multiply the 4 in the denominator. What we're doing here is we're trying to make sure that our denominators are the same. Then minus a 5 over a 1, meaning the denominator 4 in the first fraction should multiply the numerator and then also go on to multiply the denominator. Now let's see what we're going to have as a result. A 15 times 1 is a 15. And a 4 times 1 is a 4. Meaning the equivalent fraction, meaning this 15 over 4, is the same as the fraction that we had initially. That is, and then minus a 5 times 4 is a 20. Likewise, 1 times 4 is a 4. Meaning 20 over 4 is equivalent to a 5 over 1 that we had in our previous fraction. Now, if you observe the newly formed fractions, you will agree with me that the denominators are the same. What are we to do here? We need to look for the difference of the two numerators. That is 15 minus a 20 all over the common fraction 4. And the 15 minus 20, that is to say you have $15 and you are asked to pay back $20. Obviously you can't, you only have to run in a deficit. So a 15 minus 20 will not give us a 5, but instead a minus 5 divided by a 4. So what we're going to have here is a minus 5 over a 4. Is this simplified? It is not. Now, since it is not well simplified, is there any number that could divide the 5 and the 4 without any remainder? There is no such number. Now, let's look at the two numbers. Where do we have the least number? That is in the denominator. The 4 is less than a 5. So what we're going to do here is to use the 4 itself. Meaning, this negative sign does not have what to cancel it, but the number of 4s in 5 is 1. Remember what? The 1 over 4. Meaning our result here will be a negative 1 over 4. Next slide, or to the next question. We are asked to simplify a 1 whole number 4 over 5 divided by a 9 minus 1 over 12 of 2 plus 1 over 3. Now, what have you observed with this question? We've got mixed numbers among the numbers given. So what we're going to do here is to make sure that the mixed numbers are changed to improper fractions. And as such, we're going to have the 1 whole number 4 over 5 written as a 9 over 5. How do we arrive at that? That is, the denominator of 5 multiplies the whole number 1 and then the numerator added to it. The result attained should be divided by 5. That is, a 5 times 1 is a 5, plus 4, which is a numerator, will give us a 9. And then because the 5 is the denominator, we have to divide everything by that, by the 5. Meaning 1 whole number 4 over 5 is 9 over 5. Divided by a 9 minus a 1 over 12 of a 2 plus a 1 over 3. Now, if you looked at this, the question is yet to be properly what? Simplified. If you looked at the question, how many operations are involved? We spoke about the division sign in there. There is a minus sign in the operation. There is a positive sign in the operation. That is a plus sign. And then we also have an off, meaning we've got more than one operation. Now, since we have got more than one operation, to solve this question, we need to what? To remind ourselves of the board mass. What does that imply? That to solve this type of questions, the bracket should be treated first. And is there any bracket in the question? No, there is no bracket. What else is in the bracket, in the question? That is an O. What does that imply? An off. And off here is in the question, meaning we have to solve that first. Since there is no bracket, an off should be solved. Next. So we'll have our 9 over 5 divided by a 9 minus what is now in our new bracket, that is 1 over 12. The off here is changed to multiplication, or multiplied by a 2 plus a 1 over 3. Now, what is in the bracket that can cancel out? That is a 2 and a 12. The number of 2's in itself and the number of 2's in 12 is a 6. So to take on our problem, we'll have a 9 over 5 divided by a 9 minus the result of what we have in the bracket, that is a 1 times 1, which is a 1, all over the denominator 6 is 1 over 6, plus a 1 over 3. How many operations are we left with? We've got 3 operations. The division sign, the minus sign, and the plus sign. Which one comes next after the off? Is the division in the word what? Board mass. Is there any division? Of course there is. What is dividing what? 9 over 5 is dividing a 9. So we also have to enclose that in a bracket, meaning we have to have that solved next. That is a 9 over 5 times a 1 over 9, because what we are told here is each time you change the division sign to multiplication sign, the number next to it has to be inverse, and the number next to the division sign is a 9. So the inverse of 9 is 1 over 9, and this is why we have a 9 over 5 multiplying the 1 over 9 minus a 1 over 6 plus a 1 over 3. Is there anything that could be further simplified in the bracket? Yes, there is. That is, this 9 could simplify this other 9, meaning the number of 9's in 9 is 1, and the number of 9's in another, in the 9 that serves as the denominator here is also 1. So what will we have as our new fraction in the bracket? That is a 1 times 1, that is the numerators that I am multiplying. A 1 times 1 is obviously a 1. And then see if you could also multiply the denominators. That is a 5 times a 1, which is 5. Meaning a 9 over 5 divided by a 9 will leave us with a 1 over 5 minus a 1 over 6 plus a 1 over 3. Here we have 2 operations. And what are these 2 operations? That is addition and subtraction. If you can recall the lessons you had before this one, you will agree with me that you were adding and also subtracting fractions with a different denominators, or with different denominators. How were you doing it? That is, the first fraction, which is 1 over 5, the denominators of the fractions involved should multiply the numerator and then the denominator. And what are the fractions that were involved? Those denominators is the 6 and the 3. So the 1 has to be multiplied by 6, and then also be multiplied by 3. And then the denominator 5 should also be multiplied by 6 and also a 3. Then minus 1 over 6, which is the second fraction, should also what? Be multiplied by 5 of the first bracket and the denominator 3 of the second bracket. Since we've multiplied the 1 by 5 and 3, we should also multiply the denominator 6 by 5 and 3. And then the final fraction, which is 1 over 3, the same approach. Meaning the denominator 5 of the first fraction should multiply the 1, and the denominator 6 should also go on to multiply the same one. And then do the same thing in the denominator. That is, the 3 has to be multiplied by 6. Let's see what we're going to have as our new product. That is, a 1 times 6 is a 6. A 6 times 3 is an 18. All over. What is the product that we're going to have in the first fraction? In the denominators. We have a 5 times 6 is 30. A 30 times 3 is 90. So an 18 over 90 is replacing the first fraction 1 over 5. How? They are more or less the same, because the simplification of 18 over 90 could lead us to 1 over 5 that we have in our first fraction. Then minus a 1 times 5 is 5 times a 3 that is in the second fraction. We'll have a 15 all over. A 6 times 5 is 30 times a 3 is 90. Meaning the second fraction, which is a, that is to say, when you simplify the 15 over 90, you will get back to 1 over 6. Plus the final fraction, which is 1 over 3. What is going to be the equivalent to that? That is a 1 times 5 times a 6. That is 1 times 5 is 18 minus is a 3. A 3 plus 30 is 33. All over what? 90. Now, we have a 33 over 90. Can this be further simplified? Yes, it can. And how are we going to simplify it? Meaning we'll look for a number that will divide the 33 and also the 90 without leaving any remainder. And what is that number? Could be a 3. How many 3's are in this 3? Is 1. That is the first 3. Is 1. And how many 3's are in the second 3? Is also 1. Meaning the number of 3's in 33 is 11. Now, let's use the same 3 to see if it will also divide the 90 without leaving any remainder. The number of 3's in 9 is 3 times. But how many groups of 3 are in 0? Is 0. Meaning the number of 3's in 90 is 30. So to simplify a 33 over 90 will leave us with an 11 over 30. Can this be further simplified? Is there any number that could divide the 11 and the 30 without any remainder? There isn't. Now, if you also looked at the two numbers, where do we have the least number? That is in the numerator. That is 11. Meaning, this could not be further simplified. Our result could either be 11 over 30 or you leave it in decimal fractions. I thank you so very much for listening to the lectures, and I pray that you stay safe in your homes from the cloud, and make sure that you listen to the subsequent lessons that will follow this one that I had. Thank you very much.
Fellow Gambians, my government has approved a 500 million convenience.
xaalis bi tege yomb na waaye mu lu jafe mooy séddale bi niñ ko séddalee ak ndax danañ ko jox ñi ko yeeyoo wala duñ leen ko jox loolu moo jara laaj.
cos loo xam ne la nit yee tax ñu joxe ko te nit ñi ñoo leen fa teg te xaalis nit yi la comme xaalis population bi la wax dëgg yàlla li gënoon mooy ku nekk gis sa boppa
man su ma sañoon daal ñu séddoo ko nu mu waroo buñ si def xaaj loo ñii diw nañ ko si ku nekk loo war a am nga am ko.
askan bi seen dem ak dikk bu ñu wàññee mu jël ko def ko si loolu noonu participer ko si loolu noonu ba nga xam ne danañ mën